Apart from solid waste, the campus generates large amount of liquid waste as well. It was in 1960 when the first concrete step towards liquid waste management was taken. Back then, the entire campus population was concentrated to the north of a distributory running from the east to west of the campus land, while the southern area remained untouched. To manage the generated liquid waste, the entire northern area was divided into 5 zones, each provided with sump wells at strategic important locations. This elaborate system was designed for sewage to flow under gravity. The sewage was collected and transported via a network of sump wells and fed into the oxidation pond on the northern end of the campus, where it got oxidized. This partially treated water was used for horticulture needs of the surrounding area, which has now turned into a pristine orchard. In the last 5 years, about 200 fruit trees have been planted in the orchard, including guava, mango, chiku and bear trees. Many bird varieties can be easily spotted here, like the kingfisher, woodpecker and Indian tree pie. The orchard is also frequented by several vibrant migratory birds who keep coming and going. In 2009, the Institute took another crucial step in this direction. It installed sewage treatment plants in the campus, thus advocating the 3 R's of the waste management strategy: reduce, reuse and recycle. Each sump well has one sewage treatment plant that recycles the sewage collected from the nearby areas. As the years passed by, the campus population increased and the southern area of the campus began teeming with life, thus adding to the liquid waste generated in the campus premises. Since technically it was not feasible to pump the liquid waste from the south to north zone, another sump well 10 and an oxidation pond to collect the sewage from it were built near Hall 8. The sewage treatment plants installed at each sump well are biotreatment based plants. This setup comprises a primary settling chamber, 3 rotating discs also known as rotors and a lamella zone. The sewage from the adjoining areas flows under gravity and is collected in a sump well. From here, it is pumped into the plant. The first chamber of the plant is the settling chamber, where large particles in the sewage settle down. The sewage is then lifted to the first rotor, known as the lifting rotor. Lifting rotor lifts it further to the aerobic rotor, where aerobic aeration takes place. Aerobic aeration is a process where bacteria act on the sludge, eating away the organic matter and cleaning it. From second rotor, it is lifted to the third rotor, where secondary aeration takes place. It then enters the lamella zone, where heavy particles settle down. To further disinfect the treated water, it is subjected to chlorination. In the last stages of the treatment, water is passed through two filters. From chlorination zone, the treated water enters into the breaker tank, from where it is lifted through pumps into the sand filters. These filters remove the suspended particles left behind in water. Finally, the water enters into the carbon filters for final removal of any foul odor left behind. Beside the oxidation pond, another water body was constructed to collect rainwater and used swimming pool water to prevent it from flowing into drains. Today, this water body is used for fish farming and horticulture purposes. Water recycled at each sump well is used for gardening and other horticulture needs. Presently, the total amount of recycled water is close to 1 million litres. The samples have been tested by the UP Pollution Board and were found to be satisfactory. Also, regular testing is done in the Institute's laboratories. As per the February 2012 lab reports, the BOD level, which stood initially between 80 and 100, went down to between 7 and 12 after treatment. The COD level had also reduced drastically, thus rendering the recycled water suitable for horticulture purposes. Our ultimate goal is not to discharge any untreated water to drains and maximize the use of recycled water. As the campus population increases, the recycling capacity will be increased. The Institute will endeavour to exceed the requirements of relevant environmental legislation and to improve the standards of environmental management. Well, the future looks very vibrant. The Institute is planning to turn the zone into a recreational park offering a variety of leisure activities like boating and fishing. The area with its scenic beauty and clean water bodies will truly be a picturesque place, providing a refreshing break to the campus residents.